Okay, for number 2, same kind of thing. This time I just have a log equals number equation, but I still want to condense anywhere I can. So on the left-hand side, again, I see addition of 2 logarithms, meaning I'm going to multiply the arguments together. So I'm going to rewrite this as log base 8 of 2 times 4x squared equals 1. Then from there, I'm going to want to get rid of the log base 8. And in order to do that, I'm going to exponentiate with a base of 8 on both sides. 8 to the log base 8, those are going to say see you later. On the other side, though, I have a new number, 8 to the first. Okay, so when I rewrite this, the log is no longer there, and I have 2 times 4x squared equals 8 to the first, which is just 8. Now, I know I see an x squared in this equation, but it's the only x that I see. There's only one variable occurrence. So I can just do inverse operations to get that by itself, okay? What I would want to do first, though, I would multiply your 2 and your 4 together on the first side and get 8x squared equals 8. Then divide both sides by 8 to get x squared equals 1. Then I'll take a square root and get x equals plus or minus 1. And just like with the previous problem, I want to check to see if these solutions are valid or extraneous. So I'm going to take both of these solutions, x equals positive 1 and x equals negative 1, and plug it into the original function or the original equation where I see the x. Okay, so if I take the number positive 1, 4 times positive 1 squared is going to be 4 times 1, which is just 4, meaning that positive 1 is a valid solution. I did not get a negative or a 0 argument. If I plug in negative 1, 4 times negative 1 squared, well, if I square the negative 1, I get positive 1, times 4 is still just 4. So these answers are actually both valid. Because again, when I plugged them back in, I did not get a 0 or a negative argument.